The big G, gravity. What is it? We can calculate its effects, but we have a loose understanding of what actually causes it. It affects us every day, like other physical forces, but gravity is the force that we notice the most and have to live with and struggle against. What exactly causes this struggle? I will embark to answer this question, and I warn you, this is a series of abstract ideas to explain not just gravity, but other phenomena that occur at very small scales, or at the quantum level. Be prepared to open your mind. Sir Isaac Newton gave us a lasting gift when he discovered mathematics that allow us to determine how multiple bodies will interact gravitationally. For the most part, what Newton discovered works. Do we really need to understand anything more about it? Absolutely. After Isaac Newton, Albert Einstein fell onto the scene with a groundbreaking way of looking at the universe, and our understanding deepened. Einstein proposed that space and time are relative, and that matter and mass act to bend space and time, causing the effects of gravity. More recently, contributing to Einstein's vexation, our understanding of the universe has broadened to include weird quantum phenomena. We have discovered strange ways in which matter acts at increasingly smaller scales and still not found an answer for gravity. The problem worsens with these strange quantum observations. They take us farther away from understanding and closer to ignorance of our universe. This is the way of science. I'm going to address what I believe causes gravity, but I will also address material correlated with quantum mechanics, specifically the double-slit experiment and wave-particle duality. The reason being that I believe that wave-particle duality is evidence for what causes gravity. In 1924, French physicist Louis de Broglie proposed that discrete particles such as photons and electrons can also express wave-like properties. This is most evident through a particular experiment, the double slit. In the experiment, individual particles are propelled through a set of narrow slits and then into a detector. The detector will confirm discrete particles are being received from the source, but oddly, as more and more particles are received, a peculiar pattern emerges. The pattern is that of a wave interference. Wave interference is something that is indicative of waves. So, is it a particle or is it a wave? This question has invoked the expression that discrete subatomic particles can also act as waves, hence the term wave-particle duality. This is just the tiptoe of a large monster that began to emerge in physics. The idea of a particle also acting as a wave is abstract and baffling to anyone who endeavors to understand it. You might be familiar with the following statement. We don't know why this is happening. We might have to wipe the drawing board clean and start all over. This is something I've heard a lot when consuming scientific presentations about cosmic and subatomic subjects. The oddity of this statement is the drawing board is never wiped clean. Everything is just rewritten again and again. In my search for a better understanding and new ideas, I came across Wal Thornhill's theory of gravity. Wal had a way of actually wiping the board clean and coming up with a new theory, a new lens, and a new language. Wal Thornhill proposed that gravity is caused by interactions between atoms, resulting in variations of distance between subatomic particles that comprise the structure of the atom. The result of these variances produces a dipole in each atom that causes a weak attraction to nearby matter. Nearby matter, likewise, experiences the same distorting and dipole attraction. There are levels of attraction that exist between atoms and molecules. These attractions are electrostatic. They obey Coulomb's law and result in chemical bonds of compounds and subsequent intermolecular bonding. It's a hierarchy of attraction that can extend past a single bond between atoms, exhibiting secondary attractions. These levels of attraction govern how large molecules form chains of carbon and amino acids in DNA, while secondary attractions produce the helical shape of the DNA. Thornhill is suggesting that gravity is another level of attraction within the existing framework of charge, attraction, and repulsion. This idea is attractive. Firstly, because similar to Coulomb's law, gravity also follows an inverse square law. Secondly, Thornhill's approach is an attempt to simplify our understanding by using an existing law. Third, no one introduces new ideas, so it's fun to entertain a new hypothesis. What Thornhill is suggesting is that matter bends matter. This is subtly different from what Einstein suggested, that matter bends space-time. I've preferred Thornhill's interpretation better, because I've always considered space to be infinite in size and having no properties, but only containing matter. If space has no properties, then how is it capable of bending? After pondering this subject for several years, I believe Einstein and Thornhill may both be a little wrong, and perhaps both are a little right. Likewise, I may have been wrong about my interpretation of space. There are some problems with Thornhill's theory, and these inconsistencies are laid out in an upload by Gareth Samuel to his YouTube channel, See the Pattern, link in the description. The problem ultimately lies in the dipole concept. Dipoles between two bodies would form properly, but when another body is introduced, the theory breaks down. Take, for example, the Earth and Moon. We would assume that distortions are producing dipoles within the Earth and Moon. If both bodies are of the same polarity, they would be repelled. In this case, we would assume they are of a different polarity, and this seemingly works. However, when we consider adding the Sun into the equation, we have to assume that at least one of the bodies would be repelling another, and this does not seem to be the case. Even more evident would be the moons of Jupiter and Saturn. These planets have over 200 moons combined, and their moons don't repel each other in any way. With that being said, I still think Thornhill is correct about distortions pulling weight in the matter, and also the assumption regarding secondary attractions. But this is where I begin to diverge from Thornhill's original proposal. I am inclined to believe that the motion of subatomic particles is key to explaining distortions that produce gravitational attraction. At the moment, I would like to discuss mass and the neutron. However, I'm going to undertake that in a future video, as I do think it's possible to ascertain mass using the following ideas. As for the neutron, because it is neutral, we will assume the neutron is a proton-electron pair and acts like a neutral atom. Let's consider that all electrons are exactly the same, and all protons are exactly the same. I think anyone can agree with this. But let's consider now that because they are all the same and have the same properties, they are all derived from the same source. Meaning, when you interact with one electron, you are interacting with them all. I like to consider all positive and negative charges being connected together and bound toward the opposite charge, wherever the opposite charge may be. This idea is related to the single electron theory and also quantum field theory. This is why like charges repel, because they cannot move towards something they are rigidly connected to. With this in mind, even though our electrons and protons are bound up inside our bodies, they are still on a path towards the subatomic structures of other atoms, including the Earth. This would suggest that there is a constant motion, a push and pull of the subatomic world. Here we have two atoms side by side. The electrons are bound to their respective nucleus, but they are still attracted to the nucleus of the other atom. When the electrons in atom A move toward the nucleus of atom B, they will repel the electrons that are bound to atom B's nucleus. This would expose atom B's nucleus to atom A's electrons, and the result would be a secondary dipole attraction that Wal Thornhill describes. Likewise, the electrons in atom B would move toward the nucleus of atom A, repelling its electrons, exposing atom A's nucleus to a secondary attraction. This back and forth motion would produce what we refer to gravitational acceleration. But alas, this would bring us right back into the dipole problem that we noted with Thornhills theory. Although this constant motion might begin to explain some of the quantum weirdness described earlier, how do we get past the dipole problem? It would seem that we need a motion or distortion that only attracts. We need a monopole. I believe there is an answer for this, and you will scoff. But let's consider. The push and pull of subatomic particles towards one another happens, drumroll please, instantaneously. This answers the dipole problem by allowing for monopoles to exist. We might even consider that particles are in superposition with one another. This would suggest a gravitationally polarized Earth can show its positive and negative face at the same time, as well as the moon and sun. All bodies can move towards one another because their subatomic charges are in superposition with one another. Imagine, all the charges in your body are moving so fast, it's not possible to witness their motion. But so are the charges of the Earth, and therefore you can see the resulting gravitational attraction, but not the motion that furnishes it. With an instantaneous motion, we could even suggest that all subatomic particles of the entire universe are flowing into one another, like a supercircuit. Sounds amazing, no doubt. I'm not going to suggest that, though. Now, before you get your atoms all entangled, let me indulge some questions you might be asking regarding an instantaneous motion, or what I like to call probabilistic motion. Isn't the speed of light the max speed of the universe? Not exactly. In 1932, a term known as quantum entanglement was coined by Erwin Schrödinger. Even Einstein didn't agree with this talk of quantum mechanics. Einstein and his colleagues published a paper claiming that quantum mechanics isn't a workable theory and isn't compatible with classical mechanics. To Einstein's chagrin, Schrödinger was correct with his assumptions. We now know via experiment that two particles can be entangled and have their wave functions collapse instantly, no matter how great the distance between the particles. When the wave of one collapses, the entangled particle's wave also collapses. This suggests that information has no maximum speed. I'm suggesting that in some way, all particles are entangled. Quantum mechanics is all about probability. If you have been paying attention, I refer to the instant motion of particles as probabilistic motion. Imagine, you are standing at one side of a room, and you can travel to the opposite side instantly. You would have the potential to be at both sides of the room at the same time. There is no limit to how many times you could travel back and forth in the smallest amount of time, or in no time at all. I'll admit this sounds crazy and unrealistic. But let's say you wanted to give someone a high five at one side of the room. Technically, for a brief moment, you would have to actually be on that side of the room to make contact. The reason this sounds so strange and improbable is because we are mixing infinite potential with finite results. We can visualize this with a simple equation, infinity plus 1. We could say infinity plus any number equals infinity. Or we could say that infinity is irrelevant or negligible. It's merely a probability, and therefore infinity plus 1 equals 1. Another good example is a bingo cage. Does it really matter if the bingo balls move around instantly inside the cage, if in the end, the caller can only pick one ball at a time? I say the results are virtually the same, hence the term probabilistic motion. The motion is so fast that it can only be visible via probabilistic waveforms, or as quantum mechanics calls it, wave function. This brings us back to the double slit experiment and wave-particle duality. If we consider probabilistic motion, wave-particle duality is achieved. We can suggest that a particle may have a velocity that carries it forward, but which still experiences probabilistic motion. We would assume that this motion is somewhat perpendicular to its direction. This way, a particle can always be a particle. However, the particle travels instantly to all points within a local area, perpendicular to its direction. This would produce the wave function of quantum mechanics. This could also explain why a single photon can be fired at a pair of slits and seem to travel through both slits and interfere with itself. It's because it actually does, exhibiting instantaneous, probabilistic motion. Now you might have thought of another question that arises from an instantaneous and never-ending motion. That is, if particles are in constant motion, why do they never lose momentum, slow down, or stop altogether? This is a good question, because when considering new ideas, we want things to obey conservation of energy. The good news? I believe I have an answer. Not only that, but I also think we can get an idea of the origins of energy itself. We return to the subject of Thornhill's matter-bending matter, or Einstein's matter-bending space. If our theory is that matter is in constant motion without ceasing, then we need an infinite source of energy, something that never runs out. The answer lies in space itself. As far as we know, space is the only object that goes on forever and has no limit. That being said, I think it is the only object that can be considered a plausible source that imparts its infinite properties into matter, producing unlimited movement. In retrospect, this would suggest that space actually bends matter. This is slightly different from Thornhill's, Einstein's, and my recent interpretation of how space works. It also puts a twist on Thornhill's distortions that produce the secondary gravitational attraction. I hold to the idea that the distortions are a characteristic of subatomic particles interacting with space. This would be the result of matter taking up space, while space, in return, continuously invades the area where the particle resides, moving its location. Because space is infinite, its ability to invade and move the particle around is unlimited. We might even surmise that this is where energy itself comes from the probabilistic motion of particles imparted to them by space. When we produce energy, we are merely scraping off the top of an infinite energy source. We may even guess the reason mass and energy are related, that is, due to a form of resistance from probabilistic motion. In conclusion, it's not that matter bends space, or that matter bends matter, but the relationship between matter and space that causes gravity. It's like every particle inside us, the Earth and our universe, is interconnected through a field of motion induced by space. Everything jostles back and forth, imparting its motion into everything else. This is the result of an endless, unlimited, and eternal void that permeates all matter, giving everything its energy. I think this is a truly profound way of perceiving our universe.